Aloha, I'm Brian Glazer. I'm a professor of oceanography at the University of Hawaii and co-founder of Hohuno. We're a team that are absolutely obsessed with measuring the environment on appropriate scales to identify, predict, and solve problems that are emerging because of accelerating climate change. So the atmosphere and oceans are warming at unprecedented rates. Carbon dioxide levels are higher than they ever have been in human history. This summer, Greenland melted at a rate that wasn't predicted until 2070. Corals are bleaching. This is caused by a combination of temperature, hydrodynamics, light, pH, nutrients, disease, and genetics. But how much each of these variables affects corals? Why is one bleaching and white? Why is one of its nearest neighbors brown and healthy? They are an open question. There are no cost-effective tools to make all of those measurements at the biologically relevant spatial scales that the individuals are experiencing. So we tried to tackle that. We partnered with Ruth Gates and other coral reef biologist friends and created microsensor arrays for measuring at least two of those variables, light and temperature at 0.1 degrees C accuracy, on a biologically relevant spatial scale. This is absolutely key to understanding the variability. If you want to go save corals, you have to save the right ones that are predisposed to surviving these kinds of events and will then regain their symbionts. So the planet is warming, oceans are changing, sea levels are rising, organisms are affected, including humans. Right? We explored this idea of expanding that biologically relevant spatial scale approach to other rapidly climate change-induced problems. Impacts of episodic flooding are an obvious low-hanging fruit here. They're an area of prioritization for us. There's a 10% chance of sea level rise of 2 meters by 2100. Charleston, South Carolina had 58 coastal flood events in 2019. The philosopher-musicians, the Red Hot Chili Peppers, said, "Destruction leads to a very rough road, but it also breeds creation." It did for us. When NOAA goes out and installs a tide gauge, it looks like the background there. It's a few technicians, a couple of days' time, $125,000 in equipment. When we do it, it looks like the foreground. It's about $250 in parts. Undergrad level mechanical and electrical engineers in my lab can build these and deploy them from scratch. Our data on the right half of the screen is just as good as NOAA's gold standards. So not only can we occupy new stations, we can then provide predictive analytics to predict tides in new locations. This idea of understanding at appropriate scale is infectious. It's not just a research project. So over the last few years, researchers like me, environmental restoration nonprofits, educators, cities, counties, municipalities, dredging companies, sailing clubs, they're all hungry for tech solutions to environmental problems like sea level rise and episodic flooding. So realizing these cost savings that come from rapid prototyping because of 3D printing, a part that used to cost me $1,000 to prototype now can be drawn by an undergrad, and we can prototype the part 3D printed in hours. It changes everything. So cloud computing, web and mobile tools, we're partnering with the University of San Francisco Data Science Institute to actually provide some machine learning algorithms that are outperforming NOAA's gold standards for tide predictions. We can do this in mobile format as well and take it to the masses. So for years, these kinds of data sets were only available to climate scientists or federal or academic scientists. Now we're providing it for new groups. We're gaining traction. It's not just a research experiment. People are willing to pay for this kind of information at the appropriate scale. We've deployed over 200 sensors in 5 years in 5 states. We've scaled from a small research experiment to something that I think has legs. Technology alone is not the differentiator. We have a great team. A friend, I went to high school and college together with Nicole. We co-founded this company. What Nicole has an expertise in coastal geology, thinking about beach replenishment, fills in the gaps from my oceanographic background. Stanley does not sleep. He is a stallion engineer. He can build anything for us. He has done most of our programming. I was incredibly lucky to find him right out of grad school. And then I told folks who were urging us to think about commercialization, I have tenure. I'm a professor. I do research. Why would I start a company? Find me some people who would run the business side of this. And Donovan K. Aloha has been absolutely instrumental for us for that. He successfully started a company out of UH and is now a venture capitalist here in the Bay Area. It's just the beginning. Thanks to Nicole, we already have more tide gauges in South Carolina than NOAA. We have started a partnership with the Honolulu Board of Water Supply as early warning for flood mitigation on Oahu. We're talking with the Army Corps of Engineers to help them with a $300 million restoration project and flood mitigation project in the Alawai Canal. And we're partnering with the Polynesian Voyaging Society to take this kind of idea of sustainability blending indigenous knowledge with contemporary technology for emerging problems to 50 countries over the next 5 years. If you have any questions, please approach Nicole or I. I want to leave you with another quote. Henry Bigelow, co-founder of the Woods Hole Oceanographic Institute, said, "Nothing in the sea falls haphazard. If we cannot predict, it's because we do not understand the cause or how the cause works," in 1929. It's just as true today, and if I have to pay $25,000 or $125,000 for an instrument to measure data, we're not measuring the data at the correct granularity to solve the problems. I'll leave it with that.